way you have a rectified voltage, right? It's not going positive, negative anymore, which is one step closer to that constant DC voltage that you're looking for. Now, if you're looking for a constant positive DC voltage, this is good. If you're looking for constant negative voltage, the other one is good. Questions?
You say constant positive voltage, but there's still a point in the middle of the graph where it's 0. How would you change that?
This is nowhere close to what I'm looking for.
Yeah.
I said I'm looking for a constant voltage. I'm not there yet.
Oh, okay.
So I have to do a lot more before it becomes constant. So I do what? I filter. What's a filter? Yes. So it's basically just a capacitor. I have this signal now, right? A signal that does this. This is your source. This part, you can now turn this into a source that has that shape, right? And then put a capacitor right in here. So this would be your circuit. This is the voltage that is going to that circuit. So if you want to show it as a complete circuit all the way to this point, this is what you have with the source, right? And this is the complete one. When it reaches here, it turns into something else before you put the capacitor. And now you put the capacitor. Okay? So let's see what happens. So the current comes in, and then it sees RC, okay, in parallel. When it starts going and the capacitor is basically discharged, like there's no charge in it, all that current is going to start going into the capacitor. That's like a short, right, for when there's no charge in it. There's no electrical field to repel the incoming charges, right? So they're going to directly go into that. But as it builds up, less is going to go to the capacitor and more is going to go to the resistor, right? If you didn't have a resistor, or if you can ignore the resistor in this part of the calculation, meaning that the resistor is so large that you can ignore the effect of it against the effect of the capacitor. Let's say that is the case. So what happens? The diode turns on and all the current goes to the capacitor, and it's basically a short, right? Minus 0.7 volts here is the voltage here. So what would be the voltage of the capacitor? It's just the same voltage, right? Meaning that when it goes up, it's just going to start the first time that it goes up. The capacitor voltage is going to go up, charge up, and reach here, right? And then the voltage goes down, right? What does that mean? That means that now the voltage on this end is going to become less than the voltage on the other end. What happens to the diode? It turns off. So it turns off, and then since it has turned off, and I'm ignoring the resistor, the current or the charge has nowhere to go. It just stays right there. Right there, wherever.
Doesn't the capacitor discharge?
No, there's no way for it to discharge. I said I'm ignoring the resistor. Right? So it just goes up there and just stays there.
Well, but it still discharges, doesn't it? You can't just have a capacitor wherever it goes charged.
Why not?
Isn't that why you refresh your RAM? Because it loses charge?
Ooh, that was way advanced. It's just a capacitor. I don't know what you're talking about.
Okay.
You're correct, but I want you to think more about it. Why not? If the charge goes on across two electrodes, why would you lose charge?
When you unplug it out of the wall, it discharges?
Hmm?
When you unplug it out of the wall,